Good, YouTube. Welcome back to one of my videos. My name is Ms. V, and as you guys know, on this channel, I focus on math content, and right now I'm specifically focusing on geometry. So if you guys are interested in learning more about geometry, today what we're going to be talking about is the specific properties of rigid motion. So a lot of times we will talk about, translations, reflections, rotations, all that kind of stuff, but we won't really mention what kind of properties are directly related to the relationship between the pre-image and the image. So today I'm going to go ahead and I'm going to show you guys those properties. So I'm just going to jump right into it. And as always, if y'all see me looking down, it's because I'm writing on my iPad. But without further ado, let's go ahead and talk about the properties of rigid motions, okay? And today I'm going to be talking about all three of them. I'm not really going to give any examples today. It's just kind of like the properties itself and how you can tell the difference between the three of them. So I'm going to go ahead and start off with our translation. So as you all should know, a translation is basically a slide of your figure. So if you don't know that, you can go ahead and watch my video on translations, and I go ahead and I go over an example of it, all that kind of stuff. So you can go ahead and watch that video. It will be linked in the description below. But here we have a coordinate grid, and I'm going to do my pre-image in red and my image in green. Okay, so pre-image is before I do the translation. So let's start off with a kite, you could say, kind of like a rhombus, okay? So I'm going to go ahead and I'm going to translate that rhombus, and I'm going to translate it 1, 2, 3, 4 units to the right. So 4 units right, and I'm going to go 4 units right, and let's do 2 units down, okay? So 4 to the right and 2 down. So now this point, we'll say this is point A, B, C, and D. So now A prime is going to be right over here. Okay, so now with D, we're going to go 1, 2, 3, 4, 1, 2. And I know that it's not really on a point specifically in that drawing, but y'all get the gist. 1, 2, 3, 4, and 2 down. This is going to be B prime. And C, 1, 2, 3, 4, and 2 down. This will be C prime. Okay, so this is kind of like that same figure. Just that time I actually have it on points. So the property of translation specifically, if I were to draw a line segment connecting the point of the pre-image to the image, if I were to do that for each of these points, so let's say I draw a line segment connecting C and C prime, connecting B and B prime, and connecting A and A prime. If you notice, all of those line segments are going to be parallel to each other, okay? So those line segments are never going to intersect. So whenever you do a translation, whenever you translate the pre-image to the image, if you draw line segments connecting the pre-image point to the image point, all of those lines are going to be parallel to each other, and they're also going to be the same length. So A prime, that line segment is going to be the same as B prime, and C prime, and D prime, okay? And that's just a way to notate a line segment. Because if you think about it, your translation, you're translating the figure by the same exact units. We're translating the whole figure 4 units to the right and 2 units down. So there's no possible way for those line segments to be different lengths because you're moving the figure in the same exact direction, okay? So those line segments are all going to be parallel. They're all going to equal each other, and they're also all going to be parallel to each other, okay? And this is how we notate parallel. So when you say that 2 lines are parallel, this is the notation. It's just basically 2 lines that don't intersect, 2 line segments that don't intersect. And then equals, it just means that they're all equal to each other, okay? So this is for translations. The next rigid motion that we have is reflections. So with a reflection, and I'm going to go ahead and remember, a reflection is just a flip. Okay, so you have your figure here, flip it. That's a reflection. And again, I'm going to draw out my little coordinate grid for y'all. And I'm going to go ahead and draw a figure. And this time I'm going to use an easier figure. So again, my pre-image is going to be in red, and I'm just going to do we'll do like a little house, I guess. In math terms, that's a pentagon, okay? So I'm going to reflect that pentagon about the y-axis, okay? So reflect about the y-axis. Okay. And again, if you don't know what that means, I have a video on it, so watch that video. So I'm going to reflect it about the y-axis, and I'm going to go ahead and draw it, and then I'll label my points. You guys should always label your points first, so don't copy what I'm doing. I'm just trying to do this in a video as fast as possible. But let's go ahead and label these points, okay? So grab that pentagon, reflected it about the y-axis. So now this is A prime, this is E prime, B prime, C prime, and D prime, okay? So again, let's go ahead and draw line segments connecting the pre-image point, which is the one without the little apostrophe, to the image point. So I'm going to connect A to A prime. I'm going to connect B to B prime, C to C prime, D to D prime, and E to E prime, okay? Now, again, notice all of these lines are parallel to each other, okay? So these segments, they're not going to touch each other, but there's a very special property for reflections that is not true of translations, okay? So as we know, for translations, they're going to be parallel to each other, and they're all going to be equal as well. In this case, these segments are not equal to each other, okay? They're instead going to be equal to, so let's say if I were to measure the distance between C to the line of reflection, which in this case was the y-axis. So let me do a different green. So we reflected it about the y-axis. That is called my line of reflection. So now if I were to measure the distance, line of reflection, I couldn't read the whole word here. But if I were to measure the distance from C to the line of reflection and C prime to the line of reflection, that distance is going to be equal, okay? So I'm going to see if I can find a way to write that out. But basically, so the distance from the pre-image point to the line of reflection is going to equal the distance. So I'm not going to write but is going to equal distance from image point to line. I'm going to call it LOR for line of reflection, okay? So LOR stands for line of reflection. So again, if I were to measure from C to the line of reflection and from C prime to the line of reflection, that distance is going to be the same. And you can tell because from C to the line of reflection here is 3 units. 1, 2, 3. Same thing. C prime to the line of reflection is 1, 2, 3 units away, okay? And you can see that that's true of all of them, okay? And then the last thing, the last important property about reflection is that all of these line segments, so A prime is actually going to be perpendicular to the line of reflection, okay? Which means that it's going to form a right angle here, okay? So parallel means that they never touch, they never intersect. Perpendicular, they're going to form a 90-degree angle, okay? So that's true of all of the segments. So A prime to the line of reflection, B prime to that line of reflection, C prime, D prime, E prime, okay? So I'm not going to write all that down, but y'all get it. So these are the 3 important properties that occur when you look at the relationship between the pre-image point and the image point for reflections. And here's for translations. And last but never least, let's go ahead and talk about our rotations, okay? So for rotations, let me pick a lighter color purple so y'all can see that better. For rotations, as we know, rotate is a turn, okay? So rotation is a turn, and let's go ahead and let me draw it out again. Oops, that came out terrible. Here we go. So let's go ahead and draw this out over here. Okay, and I'm gonna do, in this case, I think I can do a square. Okay, so I'm gonna do a square, and let me label my points and be a good teacher here. Label my points first, A, B, C, D, okay? And I'm going to rotate that square A, B, C, D. Let's rotate it. Let's do 180 degrees. Okay, so let's do 180. So A is at -2, -4. So now it'll be at 2, 4, 2, 4. I think that's 4. Yeah, this will be A prime, and then B prime, C prime, and D prime. Okay. So remember the rule for rotations, if you have X comma Y. So for rotations, you have X comma Y. When you do the rotation, all you do is make it -X, -Y. And this is for 180-degree rotation. Clockwise or counterclockwise, it doesn't matter. Okay. I think I did something wrong here. Yeah, wait a minute. Oh, I thought A was at 4. It's not, it's at -2, 3. So I got to move that down a little bit. So B is at -2, -1. So now it'll be a +2, 1. Here we go. And then this will be A. Okay. I miscounted that. So this is A, B, C, and D. Okay. There we go. That looks better. Sorry about that. I miscounted that. All right. So for rotations, the important properties, if I were to connect B to B prime, A to A prime, notice it's already a little bit different from the other ones. All of these lines are intersecting. Kind of looks pretty cool. They're all intersecting now, so it's a little bit different from reflections and translations. But one of the important properties of rotations is that all of these points, if you were to connect line segments from the pre-image to the image point, there isn't really a specific relationship between them, okay? So those line segments, there isn't really a specific relationship between them. What is important here is the relationship between each of the points and this circle right here, which is the origin, but it's also going to be our center of rotation in this case, okay? Center of rotation. So the center of rotation, as we know, is just the point that you're picking to rotate your figure around, okay? And in this case, it's the origin. So the relationship that exists here is that the image point, so distance from pre-image point to center of rotation, I'm going to call it COR for center of rotation, COR, that is going to equal the distance from image point to COR, okay? So the image from the distance from the pre-image point to your center of rotation is going to equal the distance from your image point to that center of rotation, okay? So there's no specific relationship between the actual line segments themselves here anymore. Now the relationship exists between those points, so the pre-image and image points, and that center of rotation, okay? So these are our 3 rigid motions, so rotations, reflections, and translations, and these are the different properties of them, okay? So if you guys are ever asked that on a quiz or a test or something like that, it's important to know the notation, and it's also important to be able to kind of verbalize and see how those different things connect to each other, okay? So if you enjoyed this video and it was helpful to you, please consider subscribing to my channel, like this video, and watch my other videos, especially if you were kind of lost with the different rigid motions that I talked about here. And I will see you guys on another video. Bye.